Hello Year 12 and welcome back for another video. Here we are looking at Z-scores here. This is an application of standard deviation and mean. Really? I think we're going to find it to be fairly straightforward. You've probably been exposed to this a little bit before with me telling you your Z-score or a change in Z-score on each task. Right, we'll see why it might be a good way of comparing things. Okay, so really what a Z-score is, a Z-score is how many standard deviations a particular score is away from the mean. Okay, so the way that we work it out, I take my score and I subtract the mean. That way a score that is above the mean, right, if your score is bigger than the mean, then when I take the mean away I get a positive number. If your score is less than the mean, when I take the mean away you get a negative number, right? That tells you the difference between your score and the mean, and I divide it by the standard deviation. That's the Z-score, right? It's a great way of comparing scores in different data sets. It's a great way of doing that. It's not badly affected by how many different scores are in that population. That's a good thing, so they can get bigger and smaller. It's not like a rank where, you know, 3rd out of 4 is not very good, but 3rd out of 100 is great. Something like that. No, Z-scores, it's not badly affected by those things. So let's look at an example of how we work it out. I have a mean of 600 and a standard deviation of 5. Therefore, for A, I want to calculate the Z-score for 610. So my Z-score equals the score, 610, minus the mean, 600, divided by 5 by the standard deviation. Okay, so that means this is 10 above the mean, which is 2 standard deviations. So my Z-score, unsurprisingly, is 2 there. For this one here, I have my score, 596, or I should say Z equals 596 minus the mean of 600. Now this time the score is below the mean, so I get a negative divided by the number of standard deviations, by the size of a standard deviation, which is 5. So this time I am 4 below. Negative 4 over 5 is negative 0.8. Okay, so that is a Z-score of negative 0.8. That's not terribly hard. Let's keep going. A Z-score of 1.5. Now we're going to work backwards a little bit, and I'm going to say 1.5 equals my score minus 600 over 5. Right, that means that 5 times 1.5 equals x minus 600. Therefore, x minus 600 equals 7.5. Therefore, x equals 7.5 plus 600 equals 607.5 milliliters. Oh, where did that x come from? Oh, yeah, no, x is the is my score. Oh, the score is 607.5 milliliters in there. This time, look, same thing. In fact, you know what I'm going to do is I am going to jump straight to here, and I'm going to say that my x minus 600 equals 5 times negative 2.6. I'm going to struggle to do this in my head. Here's a calculator. Righto, so for x is 5 times negative 2.6. Oh, okay, look, it's, what is it going to be? It's going to be 13. So 13 away from 600 plus 600. 13 away from 600 is 587 mils. Rightio? Wonderful. Finally, what percentage of cartons have less than 590 mils of milk? Wow, that seems like a bit of a question, but let's say that the Z-score for 590 is 590 minus 600 divided by 5, which equals negative 2. So this is 2 Z-scores below the mean. If we come back up to this curve thing here, remember, righto, 34, 13.5, 2.35, 0.15. What percentage of cartons are more than 2 standard deviations below? We couldn't do this for 2.1 or 2.2 or anything, 1.8, 1.9. We can do it when it's a nice whole number like that. So I've got 2.35 plus 0.15. Nice tie into the previous exercise equals 2.5% of all cartons. There we go. That is how we use Z-scores to do these things. I do have a couple of other examples here, but this video has hit 5 minutes, and I reckon you can work these out. So, I will fill in the answers, but I would like you to see if you can work them out on your own, please. If you've got any questions, just ask me.